Alright, in this video we're going to look at check-in number 3 and also number 4. And so we're going to look at the check-in number 4 first. And basically what this was just doing was trying to see if you knew the first couple steps for completing the square. Remember that we're completing the square because our goal is to write a function in that nice standard form where you can see all of the transformations very easily. So completing the square is making us get this little part that looks like that with that power 2. So the very first step all the time when you're going to complete the square, you can see in our goal that our x is by itself inside that parentheses. It doesn't have a number in the front. That number in the front is factored out. So our very first step is looking at the first two terms, and we would say that we would factor out the 3. That's our first step. And so that would look like f of x equals, and I make this a little bit bigger here, 3 times x squared minus 2x. And I like to leave some little spaces here for completing the square, which is the second part. Okay, so our second step to complete the square is to go over to where we just factored out the 3. And we're going to complete the square. So you're going to take that middle term, that negative 2, divide it by 2, and then square it. So negative 1 squared is 1. So that would be what I would write as my second step. You're going to complete the square. And you could just write that out, or you could show me what you're actually going to be doing, which is adding a 1 and then kind of minusing a 1. So that's the first and second step. That's all you need to do. That's all I was asking for here. All right. For check-in number 4, we're trying to just sketch a polynomial. So I'm going to draw xy axis here. And we want a polynomial. So remember, polynomials are nice, continuous, something like that. Now it has degree 5. So degree 5, the reason, one of the reasons why the degree is important is because it's telling me about that end behavior. Since this is odd, it's going to look something like our odd functions. Like I'm thinking like x to the third or x. So remember, f of x equals x is our identity. That's our line. F of x equals x to the third. That has a little kind of squiggle in it. But you can see that that end behavior is 1 going up, 1 going down. Okay. Now, it does say that we have a negative leading coefficient. So think about what happens when we put a negative in the front of x cubed. If I was looking at f of x equals negative x cubed, remember that reflects it over the x-axis, so it goes those opposite directions. And so we know that my end behavior, going back to my picture over here, will have 1 going up and 1 going down. So then it says we have 3 zeros, and they have odd multiplicity. So 3 zeros, I know I'm going to touch the x-axis 3 times, okay? So any 3 times, I'm going to mark 3 things on here, anywhere that you want. And odd multiplicity is telling me about my bouncing or going through. So since it is odd, it's going to go through. And again, I like to think back to the functions that we already know. X cubed goes through at 0, right at 0, 0. Compared to like f of x equals x squared, this has even multiplicity because of that power 2, and it bounces off that point 0, 0. So we're going to start with our end behavior. We're going to cross through. I don't know how low, it doesn't matter. We're going to have to cross through again, and then we're going to have to cross through again. So we didn't have to like write a function or anything, but just thinking about what that might look like, yeah, it would have a power x to the 5th, or I'm kind of thinking about seeing it factored out here, and this maybe looks like a 1, so, or negative 1, so I would write like x plus 1, and then this maybe looks like a 1, not really, but I'd write x minus 1, and then maybe that looks like a 3, so I put x minus 3. Now right now, all of those factors are happening only 1 time, so the total degree here would only be 3, and I'm supposed to have a degree of 5. And remember that every one of these zeros has odd multiplicity, so they have to be to an odd power. So maybe I could put like a power 3 on here, and then the other two could be powers of 1. So this right here would be an actual polynomial that meets all those requirements. But again, it wasn't asking you to come up with a polynomial. All you needed to do was give me a sketch. That should look something like that. So hope that helped.